Okay, class, this is chapter 4. So chapter 4, you will learn what happened to mineral. And then what is mineral actually? Mineral is something that it can be found naturally on the earth crust. Okay, the terms that we normally know is mineral water, right? Mineral water is also naturally can be found in earth crust, right? Gerak bumi, you can get it naturally. Okay, so the keyword here is actually naturally earth crust. Okay, so these are all the example of the stone that we can get it from the earth crust. So this is what we call ore. Ore means that it is not natural, that the mineral actually combine with other things. So in Form 1, we learn what is element, what is compound, and what is mixture, that I hope that you still remember. Element make up of one type of atom only, one type of atom, which means it is pure. Okay, for example, this is gold, 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 gold. So the whole thing here only gold. So we said that it is element. Okay, so when we say compound, compound means that it make up of more than one type of element. Okay, for example, water, H2O, water, you have one oxygen here and two hydrogen here. So this is what you call compound. Okay, so you have two type of atom here, hydrogen and oxygen, right? So this is compound and this is element. So all the element, I would say that it is not so stable because they themselves, if you look into the atom itself, this is nucleus, you have proton, neutron, proton, neutron, proton, neutron, proton, neutron, and outside you have electron, right? So the number of electron outside is actually not in balanced condition, which means we need octet. Let's say 8 electron outside, 8 electron outside at the outermost orbit, then we say that this is balanced. But most of the element that can be found on earth crust, it is not stable. That's why they tend to combine with other things. So what is the things that they tend to combine? Oxygen. Okay, for example, iron combined with oxygen, then it will become iron oxide. Aluminium combined with oxygen, then it is aluminium oxide. So beside that oxygen, they also combine with other things. So look at here. So I say metal, logam, metal combined with oxygen, so it is metal oxide. Metal combined with oxygen combined with carbon, because we have carbon dioxide. Right? So if let's say metal combined with carbon dioxide, it becomes metal carbonate. Okay, which also easily found in the natural in our environment, carbonate. Okay, if metal combined with sulfur, then it is metal sulfide. Okay, metal combined with silicon combined with oxygen, it is metal silicate. Okay, metal silicate, silicon is pasir lah. We have a lot of pasir kan, sand. Okay, so logam, pasir, oxygen, it become metal silicate. Okay, so these are all the things that you have to remember, that most of the element they tend to combine with oxygen, with sulfur dioxide, carbon dioxide, and then they can become more stable. So you look at this. This is natural element that we have: gold, silver, platinum, mercury, and diamond. And these are natural compound that can be found: bauxite, hematite, galena, cassiterite, and magnetite. You see the word here: site, type, light, all these things. All the words here means that they are actually not pure. It's actually combined with something. But when you correct something, let's say you correct aluminium oxide here, you don't want the oxygen, right? You want only pure aluminium, right? So if let's say you get gold oxide, you also don't want the oxide, you want the gold, pure gold, right? So how are you going to separate oxygen from aluminium, and how are you going to separate oxygen from, say, iron, tin, or lead? That is what we are going to learn. Okay, now look at your textbook. You have to understand, you have to read this, you have to read the name. Okay, so hematite is actually iron oxide. So inside hematite, iron oxide, right, you have iron and then you have oxygen. Iron kawin dengan oxygen, so it become iron oxide. Tin kawin dengan oxygen become tin oxide. So the glamour name is cassiterite. Quartz also, quartz is silicon plus oxygen. So silicon is like pasir lah, pasir campur dengan oxygen, so it becomes silicon oxide, that is quartz. Okay, you know that watch, the surface of watch is quartz, right? Dia tahan, dia tidak garis kan? Means that it is actually scratch free. Okay, so bauxite is aluminium ore, aluminium oxide. This one we have the mining in Malaysia, aluminium oxide. That the whole things appear to be red. Okay, it's an actually issue in our country because it causes pollution. Okay, galena is lead sulfide, pyrite is iron sulfide, calcite is calcium carbonate. So all these terms sound very new to you, but doesn't matter. You have to remember that it is actually made up of metal combined with non-metal. It's just like male kawin with female. So logam kawin dengan bukan logam, that is very natural. Okay, now look at this one. But how are we going to know the series of reactivity? How are we going to know that whether this thing we can get it pure, we can extract it by using carbon? So see, this is the series of reactivity. Okay, so for this chapter, second thing you have to know, we have a series, reactivity series of matter. So it's actually in your note, I make it as MAZIP. I wrote it very big in your note, MAZIP. So M stands for magnesium, aluminium, zinc, iron, and plumbum is actually lead. The chemical symbol is Pb, iron is Fe, zinc, and then aluminium and magnesium. Okay, so you have to remember magnesium is much more reactive compared to aluminium, and aluminium is much more reactive compared to zinc, and so on, so on. So the list here, lead is actually less reactive. So always remember MAZIP. So when the school reopen later on, I will ask you which one is actually more reactive, aluminium or iron. Then you have to say, oh, MAZIP, A is in front, so A is actually more reactive. Okay, so you remember this mnemonic, MAZIP. Okay, now you see that carbon is actually in between aluminium and zinc, which means if I have aluminium oxide, I use carbon. Carbon is actually charcoal. Charcoal. I use carbon to heat it out. I won't get pure aluminium. Tidak akan dapat. Okay. But the things that below carbon, like zinc oxide, I don't want that oxide, right? Okay. You look at this equation. Zinc oxide, I don't want this oxide, right? I want to get rid of this oxide. How? I burn it together with carbon. Then I will get zinc, pure zinc plus carbon dioxide lah. Okay, so probably I need two here to make it balance. Okay, so understand? So now look at this reactivity series. The element that below carbon, we use carbon to burn it so that we get pure matter. The element that above carbon, we cannot use carbon because they are more active compared to carbon. Okay, in other words, dia lebih cantik. So bila lebih cantik, oxygen prefer to combine with aluminium instead of carbon. Okay, yeah. So the element that below carbon can be extracted, or we say that you can actually extract the ore by using burning with carbon. The above one we use electricity. Okay, so this is the experiment that we are going to do in lab. Probably some will be demonstration. Some are actually quite dangerous. Okay, now look at this list. This is the list that happen to exist in your textbook. You see carbon is here. So the things that above carbon cannot be extracted using carbon. Okay, so the things that below carbon can be extracted using carbon. Zinc oxide, saya campur dengan carbon, you get pure zinc. Iron oxide, I campur with carbon, you get pure iron. Besi yang tulen. Okay. Tin is biji timah. Okay, timah. Biji timah, you just burn it together with oxygen, then you get pure timah. Okay. Copper also the same. Mercury, silver, and gold actually easily to get. The one that above is a bit hectic, you need to use electrolysis. So this one you will learn in Form 4. We learn this thing in Form 3. Okay, so you have to remember in exam probably they will give you objective, they will give you a list which, let's say I give you iron oxide and aluminum oxide, which of the mineral can be extracted using carbon. So is aluminum oxide or zinc oxide or iron oxide? Of course, the one that bottom lah, above cannot. Above carbon, you must use electricity, which electrolysis is the method. Okay, I hope that you remember this. Oh yeah, another thing is hydrogen. Hydrogen also another method to extract. So the same concept. The metal that below hydrogen can be extracted using hydrogen. Means that you burn it with hydrogen, then you get pure iron, pure tin, pure lead, pure copper. The things that above hydrogen we cannot use. Above hydrogen, we cannot use burning. We have to use electrolysis. So this is the diagram. It's actually all in your notes. You look properly in your note. You see that we have sulfuric acid plus diluted sulfuric acid, and then all these are acid lah. And then I put it zinc, and then it will produce hydrogen gas, right? And then you flow through here, this thing anhydrous calcium chloride will dry out the gas. So you got dry hydrogen gas. You know that hydrogen gas is flammable, right? So it flow through here, and then you heat out this one. So hydrogen will burn together with, let's say, aluminum oxide. So you know that aluminum is above hydrogen, so you cannot get pure aluminum here. But if I use iron oxide, then okay. Iron oxide here, hydrogen will combine with the oxygen, and then I will get pure iron. Okay, so we have to come back again here. This is the thing. The list also in your notes. Those who don't have printer at home, doesn't matter, you just copy lah. So it's very easy. You don't copy the entire thing. You just make a kind of like summary. You see that hydrogen with aluminum oxide, no reaction. No reaction. It does not reduce because aluminum above hydrogen. Hydrogen and zinc also no reaction because does not reduce zinc. Okay. Hydrogen with iron, yes, it is produced. Hydrogen reduce iron oxide to iron. So now you got your pure iron already lah. Lead also you get pure lead. Copper you get pure copper. Okay. Why? Because aluminum and zinc is above hydrogen, which means they are more active. Okay, prettier. Okay, now we go to this. So the conclusion of this experiment is actually this, the whole list here. The conclusion is about the whole list here. So you have to remember the position of carbon and the position of hydrogen. Okay, so that's all for the first two parts. First part, you have to know what is mineral, and then you know that mineral tend to combine with oxygen. And second part, you have to know the series of reactivity. Okay, so you already settled two parts, and then now we go to extraction of ore. Extraction of ore, that is very practical. That is what happened in factory. Show this. Okay, so you see that above carbon, extraction can be done through electrolysis. Okay, so this one we use extraction by carbon. Okay, so this one just direct heating, you can get the things already, and this is we get it quite pure already in the earth crush. Okay, so you get this is page 137 in your textbook. Okay, now the last part of the chapter is about the ore extraction. Ore extraction is like I go mining. Okay, lombong biji timah or biji besi. Okay, this is biji besi. Okay, so after mining, you get all those iron combined with oxygen, which is iron oxide, right? So you put in iron oxide here, and then you campur dengan coke. What is coke? Coke is carbon lah. carbon. Cork is actually arang batu, arang kayu, cork. And then mix it with limestone, all together, all inside. And then you can see the reaction will happen. What happened? The first thing that you come here, it is you have to brush in a very hot air here, and then this is hot air here coming in very hot, and then it go up, and then the whole thing is a very hot furnace, and then you have slag. Slag is like something that lekit, and then you can use that slag to make jalan raya, and the slag will come out, and then your pure metal will come out here. Okay, so you see that this is a slag that release, and this is a pure metal that being extracted. So what happened actually inside, we look at this diagram. Okay, all in your notes, class. So you have to make sure that you understand the whole thing. So you see that carbon plus oxygen, because we pour in all the carbon already, so carbon combined with oxygen, it is a burning furnace, so you get carbon dioxide, right? So carbon dioxide will combine furthermore with carbon, then you produce carbon monoxide. Carbon monoxide is very important here, because carbon monoxide and carbon is the one that will combine with the iron oxide. So carbon plus iron oxide, then it will form iron plus carbon dioxide. Or carbon monoxide plus iron oxide, it will form iron plus carbon dioxide. Both happen together. We can't really differentiate it because it is a closed furnace. When you close it, it normally don't have enough oxygen. It is incomplete burning. When it is incomplete burning, we produce a lot of carbon monoxide. So this happen together. Somehow you will get pure iron here. You see that? You get pure iron here, and the byproduct is carbon dioxide, just like normal burning. Even normal burning also you produce a lot of carbon monoxide. Okay, so now we come here. So the production of slag. Why is it you have slag? You have pure iron already, right? Now because slag you put in limestone, right? Limestone is calcium carbonate. So calcium carbonate, you burn it, it becomes calcium oxide plus carbon dioxide. So that calcium oxide will combine with the impurity, because when you mine the iron, right, you korek dari bumi, it of course combine with silicon dioxide. Silicon dioxide is actually pasir lah. You korek banyak besi together with pasir, right? So that pasir will combine with the slag, with the limestone that you put in, and then it become calcium silicate. So that is how we form slag or calcium silicate. This is the slag that we wanted. That is how you get the sand, pasir semua come out, and then it becomes slag. Of course, when you mine biji timah, contohnya biji timah, you korek biji timah, you tidak akan cuci it, you won't wash it clean to get rid all of the pasir, right? So what we trying to do here is we just mix it with limestone, batu kapur. We mix it with limestone. Limestone will combine with the silicon dioxide, and then it produce calcium silicate, which is quite useful that we can use it. It is in molten form, and then it will flow out. It is less dense than iron, that's why it is on top of iron. We can use it as a base of building or rod. Okay. We know that we make our rod using tar, right? So underneath tar, we actually use calcium silicate, which we call it slag. Okay, so the whole process here is just very simple. We know that carbon able to extract iron, so we just mix carbon and iron together. Another thing is that we want to make full use of the pasir, so we add in limestone, then we got calcium silicate, which we call it slag. Alright, that's all for this topic. And then the last part is the issue in Malaysia. What is the mining issue? When we have over mining, what happened? Over mining, we will have sinkhole, and then of course the burning process will release a lot of carbon dioxide, and then it causes air pollution, it causes water pollution, it destruction of the habitat due to the construction of the mine, and then sound pollution, soil erosion, sinking hole, and so on. These are the reason, or these are the issue that we are having now. That's why mining control is necessary. So because we cannot over mining the things. Okay, so this normally is we say that hot question. It seems like not so important, but it is important also in your exam. Okay, That's all for chapter 4. I will do another video for chapter 5, roughly 10 minutes. Chapter 5 is very short, and that's all. This week you have to settle your chapter 4 and chapter 5 class, chapter 4 and chapter 5, and then we will meet again during the Zoom meeting. Okay, thank you, class.